Hi everyone. Today's seminar lesson is about binomial distribution. Okay, so binomial distribution is a discrete distribution. So before we go into binomial distribution, let me review what is a discrete random variable. Okay, so discrete random variable is a quantitative variable that can take one of the countable list of distinct values. So let me highlight some important things here. It is quantitative variable, and it take one of the countable list of distinct values. Okay, for example, the number of calls that you make in a week, right? Or the number of basketball players of a team, right? Or the number of insurance you claim in a year, right? Those are countable lists because you can count, right? 1, 2, 3, 4, 5, how many number of calls you make a week, etc. There are two conditions must always apply for discrete random variable. First, the sum of all probability must equal to 1. So you add up all the probability, it must be equal to 1. Right? And the individual of probability must be between 0 and 1. Okay, and one of the important class of discrete random variables is called binomial random variable. Okay, so what does binomial random variables do is count the number of successes out of a given number of trials. So for example, if you flip the coin 10 times, right? So if you flip the coin 10 times, and we're gonna assign head will be the success event. Now, some other student might assign tail will be their success event. Doesn't matter, but here I'm gonna assign head going to be success events. So out of 10 times you flip the coins, how many times that you get the head? That will be the number of success. Okay. Okay. How do I recognize if an event is binomial distribution? So there are certain things that you can look for. First, I'm going to go back to my example of flipping coin. So flip a coin 10 times and let X be the number of heads. So this means I'm assigning head. That will be my success. Okay. So here I claim that this example is the binomial. It has a binomial distribution. Why? First, it has fixed number of independent trials determined in advance. How many? 10 times, right? I know that I'm going to flip the coin 10 times. I determined to flip the coin 10 times. That's your sample size, right? That's your sample size n, right? Fixed number of independent trials. Okay. Second, independent outcomes of trial from independent outcomes from trial to trial. Well, either I have head or tail, right? There are two independent outcomes, right? Head or tail. Two possible outcomes for each trial. One denotes as a success, and the others as a failure. Right. So like I said in the beginning, I assign head will be my success, and therefore tail. If I got a tail, that will be the failure. Right. That'll be the failure event. Success. The probability is denoted by P for every trial, and the probability of failure is 1 minus P for every trial. Okay, so P will be, so here just notation. So P will be the probability of success, and 1 minus P would be probability of failure. Okay. Or some other instructor, they use Q for the probability of failure. Okay, it's just less writing, I guess. So here, because I'm gonna assume that the coin is fair, so 50-50, right? 50-50 chance you have a head or a tail. So the probability of success here, get a head, is 50%, and the probability that you're gonna get a tail, failure, is also 50. Okay, it doesn't have to be like that all the time, right? It could be different, but here, because we assume the coin is fair, so we have 50-50 chance of getting a head or a tail. Okay. By the way, the acronym I borrowed it from one of those professors here at OCC. His name is Chep Herons. FITS. Right? It just make it easier to remember. So the the notation for a binomial distribution is here. This one right here, maybe. If I ask you what is the distribution of a binomial distribution of this example, you would write is x is binomial distribution, open parenthesis, 10, comma 0.5, where 10 is your number of trials, your sample size, right? 0.5 is your probability of success, as we know, denoted by P, right, by P. And here is binomial distribution formula. So if I ask you find the probability of getting ahead exactly 7 times or 5 times, this is how you calculate your probability. Okay, so so it is is read at n choose x times p to the x times quantity of 1 minus p to the power of n minus x. Okay, or if you want to write it in factorial form, right, is n factorial divided by x factorial times quantity of n minus x factorial. Okay, so this right here, so this one is the same thing as this one. Okay, whichever form that you want to plug in your calculator is fine, right? For me, I prefer the first one. I prefer this one because it's shorter to plug in your calculator. It's easier too. Okay, so let's go back to the example that we have. Remember the flipping the coin 10 times, and we let x be the number of heads. And we know, and we determine this is the binomial distribution. Therefore, we're going to use a formula, right? So so for example, if I ask you, I want to know the probability of flipping the heads exactly 7 times, exactly 7 times. So here, little x, your little x is 7. Your little x is 7, right? Exactly 7 times. So I want to find the probability of p of x equals 7. All you had to do is to plug in the formula, right? N choose x, 10 choose 7, times the probability of success, p, which is 0.5, like it says in the beginning, to the power of x, which is 7, right? Times 1 minus 0.5, that's your probability of failure, to the power 10 minus 7. And if we plug these all in the calculator, we got the probability of 0.117185. Okay, I'm going to show you how you're going to plug in this calculator. Okay, I'm going to show. Okay, so remember 10 to 7, 10 to 7, 10 to 7, right? So what you're going to do is you're going to use, by the way, oh, by the way, before I go to the calculator, I've been saying that it's say 10 to 7, not 10 divided by 7, okay? So make sure on your calculator, you want to find the function n choose r. That's a combination function, right? N choose r on your calculator. Let me show you how to do that. So if you have a Texas Instrument TI-84, your calculator should look like this. Let me clear all that out. So what you're gonna do is you're gonna go, I want to do 10 choose R, right? So enter 10 first. I'm gonna enter number 10, and then I'm gonna go to math and go over probability, PRB. You see math, num, complex, and PRB, right? Go over there. Go over there. And if you look down into choice number 3, you see N choose R, right? Enter that. Enter that. Here I have N choose R. Right. All I have to do is plug in number 7. Oops, what happened? What happened now? Oops, you know what? Let me clear this. I think all I have to do is just go to math, go to probability, go down N to R, and now 10 choose 7, which is 120. 120. Now, if you want to use the factorial formula, that n factorial divided by x factorial times n minus x factorial, it's the same thing. Okay, let me show you real quick. So if I want to use the factorial formula, so 10, let me go to fraction first. So go to alpha. So here, oops. Here, if you haven't know it yet, alpha and frac will give you fraction. Okay, will give you fraction. Let me delete that. So alpha frac will give me fraction, and I know 10 n factorial, which is 10 factorial. Right. How do I get that factorial notation? Go to math again, go to probability again, and number 4, there's a factorial sign there, right? So number 4 factorial, go down, x factorial, which is 7. Again, go to math, probability, number 4, enter, 7 factorial times 10 minus x, 10 minus 7, which is 3, right? 3 factorial, math, probability, 4, enter. And then it should give you 120 also. Okay, same thing. For me, I prefer the first method. It's just easier. Okay, so you don't make mistakes. It's easy. Okay, and all you have to do is you plug in p and 1 minus p and all that things and calculate it out. Okay, do step if you're not good at these at using calculator, doing this at once, do it small step. Do a small step. Okay. Okay, so the probability here is 0.112 roughly, 0.12 roughly. So roughly, if I round into 2 decimal places, 0.12 will be our answer. Okay. All right. So now, what if I ask you a different question? I want to know that what is the probability of flipping the heads at most 1 time? Remember, here I changing my wording here, right? At most 1 time. At most 1 time. So remember, binomial distribution is a discrete distribution. Remember, I say it's count distribution, right? I can count 1, 2, 3, 4, 5, right? So here, if I draw it out my number line here, and I'm gonna start at 0, okay, and then go to 1, 2, 3, all the way to what? To 10. Why? Because I flip in the coin 10 times, right? I'm flipping the coin 10 times. 10 times, and I'm going to start at 0. Why 0? 0 is if x equals 0, mean I got no head, right? I flip the coin 10 times, all 10 times is tail, no head. If x equal 1, mean I got head 1 out of 10 times. X equal 2, I got 2 heads out of 10 times, right, etc. Okay. So I want it at most 1. What does it mean to be at most 1? That mean here at most 1 is gonna, it means x is less than or equal to 1, right? X is less than or equal to 1. So what is x? X is less than or equal to 1, like in the discrete random variable. It means you're gonna choose, maybe I'll use blue here. You're gonna choose either x equal 1 and x equals 0. Because it's at most 1, right? The cutoff is right here. At most 1, the cutoff is right there. So and because it's discrete random variable, all you have to choose is either x equals 0 or n x equals 1, and then you add them up. Okay. So x equals 0. That means all you have to do is you plug in 0 for x. X equal 1, you plug in 0 for you plug in 1 for x, right? And then using the same formula, we calculate the probability. And this time is 0.0107 is what we have. Okay, right. Just be careful when you calculate these. That's all. Right? That's all. It's not that difficult. So all you have to do is be careful with the arithmetic. Okay. So that's how we calculate the binomial using binomial distribution formula to calculate the probability. Okay, another example, the number of watermelon seeds that will not germinate in a package of 20 has a binomial distribution. Sample size 20, and the probability of success is 10%, 0.1 is 10%. What is the mean value for the number of seeds that will not germinate? So here is, let me highlight something. I know statistic is very wordy. It's very wordy. So so you're gonna be able to choose out the things that you wanna focus on, right? So here they're asking you the mean value, or in another word, the expected value. Expected value, mean value, same thing, right? Expected value. And they assign the seed that will not germinate will be that's the success event. Okay, I know a little counterintuitive, but it depends how you assign things, right? But here they assign the number of seed that will not germinate, that will be the success. And they want to find the mean value. So here is the formula for mean value. Here is notation: E of x, mean expected value, equal n times p. N is sample size, right? Which is 20 here. P is the probability of success. All you have to do is take 20 times 10%, and you got 2, right? The expect value number for number of seed that will not germinate is 2 seeds. Okay. Right. And that's all I have for today about binomial distribution. Okay, thank you for watching.